My name is Mandeep Waraich, and I lead the Industrial AI Initiative for Google Cloud. Thank you so much for joining. Really delighted to have you here. At Google, we believe that the goal of every technology should be to enrich our lives, to take our societies, our collective humanity forward, and do so in a responsible manner. So we're constantly thinking of ways in which technology, and particularly AI, can help us realize this bright and promising future. So we've been thinking, how can we apply our advanced computer vision technology for solving some of the very hard incumbent problems in the industrial sectors? And how can we make these sectors more efficient and more sustainable? So in the next 50 minutes, we'll be talking about how, with industrial inspection AI that is powered by the AutoML vision technology, can help make industrial inspections more easier, faster, accurate, and more importantly, more safer. And we'll also look at how two leading companies are applying this technology to the energy and manufacturing sector. So let's get started. So AI holds great promise for solving some real-world problems. From detecting glaucoma with retinal images, to processing millions or even billions of documents to understand their content, to automatically moderating unsafe and inappropriate content. We are applying this technology across all of these use cases. But we also recognize that developing this technology, building these custom vision models, is laborious and it's hard. So we wanted to enable even the non-programmers to be able to tap into the power of AI. And that is precisely why we created AutoML Vision. So while our standard APIs are a great powerhouse for pre-trained models on the massive Google image data sets, AutoML allows you to train custom models that are specific to your industry needs, to your use case needs. How do we do that? So in a very simple, clean UI, you are able to upload the images, labeled images, if you're looking to classify a problem. Or you can draw bounding boxes, as we'll take a look, to detect specific objects within those images. Once you've done that, with a click of a button, you've got a model trained. And that model can be used to detect shark species in this case, or you can use that to detect defects, anomalies, breakage in your specific industrial products. We're already seeing use cases with wind turbine degradation inspection, with outages on solar panel farms, or failures on electric poles. And we'll be looking into some of these examples in more detail shortly. At this point, I want to take a moment to talk about data protection and privacy. So your data sets, your images, are your images. All of these custom trained models are used only on your use cases by you. Google does not pool these images into any common repositories or use this across customers. So your data sets, your images. We'll take a look at how this technology can be applied for aerial inspection in wind turbines, and then an application of that on the production line in a manufacturing company. But before I begin there, we want to share Google's stance on the use of this technology. So Google cares deeply that its technology is used for creating a positive impact in the world. And in that vein, Google created AI principles in last June. They set the standard of the application of these AI technologies. And we abide by these principles for any work that involves AI. And similarly, for the use of this technology and for this product, we expect that this technology be applied in accordance to the AI principle, which prohibit explicitly the use of this technology for any nefarious purposes. So we'll now take a look at how one of the leading energy companies in the world is applying this technology to create a brighter and greener future for us all. Let's take a look at
Global warming is one of
AES
the big
wind
challenges of
turbine
our times,
inspection.
if not the biggest challenge of our times. Now, we really do have the technology to address the issue of carbon footprint greenhouse gases from the electric sector. The AES Corporation is one of the leaders in new technologies for renewables and energy storage. It's a Fortune 500 company. Our mission is accelerating a safer and greener energy future.
Right now we have around 8 wind farms. Each farm has different capacity, starting from 50 turbines up to 300 turbines.
They cover large spans of geography and land. They're spread across hilltops and mountainsides.
All these turbines need annual inspections. Originally, it could take up to 2 weeks to do one inspection. We partnered with leading drone service company Measure. Right now, with drones, we can do it in 2 days. And this is safe and quick.
For a wind turbine inspection, we go out with our pilots, and what we're looking for is cracks or defects, things that may need to be repaired.
On a typical inspection, we're coming back with 30,000 images. Spending 4 weeks reviewing images, I don't think anyone's going to argue that that's the best use of a highly trained engineer's time.
How do we speed that up, and how do we make it 10x more efficient? That's where machine learning and AI comes in.
We've built a great end-to-end solution using Google Cloud's tools and platform. With the AutoML vision tool, we've trained it to detect damage. We're able to eliminate approximately half of the images from needing human review. The remaining 50% of their time can now be very focused on identifying that damage and really determining the right course of action to remediate it. Moving from reviewing images to training machine learning models, it's a much higher order employment opportunity for people, and one where we're trying to develop our team. Google Cloud has been a great partner. Their technology is consistently among the world leaders, and they're just a great partner to work with person to person. At the end of the day, we won't reach the cleaner energy future without advanced tools like machine learning.
Technology will allow renewable energy to be cheaper than conventional energy. Artificial intelligence, robotics, this is really what the future's all about.
Please join me in welcoming Nick Osborn from AES.
Thank you, Mandeep, and thank you to the team that put that great video together. The power industry is enormous. It touches all of our lives, and the impacts are felt around the world. The industry investments are often quoted in the trillions of dollars. The opportunities for improvement are often in the billions, if not tens or even hundreds of billions of dollars. The industry is also going through significant and profound change. Renewable energy is continuing to fall dramatically in price. Solar, wind, and battery energy storage are not just possible, but practical. The consumer is also driving change. They are much more aware of both the opportunities and the costs associated with their energy use. And the third megatrend are the new digital tools, cloud, AI, and many others that are changing the economics of insight. I'm here today to share one story where we've partnered with Google to improve lives by accelerating a safer, cleaner energy future. We call this our vision, or aerial intelligence platform. First, a little bit about myself and the company I work for. I'm Nick Osborn. I'm the business leader focused on understanding and applying advanced analytic tools like artificial intelligence and machine learning to applied business cases. Job's really quite simple. I accelerate, coordinate, and facilitate the adoption of these new tools across the organization. AES is a global power company. We're headquartered in the United States, but operate in 15 countries around the world. We've made a very significant commitment to reduce our carbon intensity by 70% by the year 2030. To help us achieve this, we've made some very significant investments in new technologies. We're the world leader in battery energy storage using lithium-ion batteries, and we're also the largest owner of solar assets in the United States. On a personal note, it feels good to come home at the end of the day and know I'm working with a company that's putting its money where its mouth is to drive that change that is core to our mission. Applying new technologies is core to how we operate our business. Our drone program is considered world-leading in the energy industry. We developed this program by partnering with Measure. Measure is a professional drone services organization, and the Measure ground control software is an enterprise-caliber drone operations platform. Through this partnership, we've improved the cost, safety, and performance of our inspections. Another consideration is that while we often hear about the threat of technology taking jobs or eliminating jobs, that's clearly not the case with what we're seeing in our drone program and many other technologies that we're exploring. We now have over 170 pilots trained in our organization, performing operations in over 100 locations around the world. These are employees with tremendous value for our company, for their personal advancement, and their broader career growth. Prior to drones, these inspections were typically done manually. So it was either someone climbing up the turbine and then rappelling down to inspect the blade, or hiking around the turbine with a large telephoto lens trying to capture an angle and trying to see if they could detect damage. Neither of these were as effective or as efficient or as safe as what we're able to do with drones. So using drones, we're now able to take that partial inspection that was taking 2 weeks of time and do a full inspection in 2 days. Much lower cost, much higher quality, in a much safer manner. It's a tremendous improvement in efficiency and velocity in our organization. But there was one new workflow. When we do a single turbine inspection, so a single turbine is around 300 images. When we do an entire field, this means we're coming back with 30,000 or even 60,000 images. This takes a lot of meticulous and detailed review to complete the inspection work. So we saw this as a great opportunity for artificial intelligence, and this is really where our partnership with Google started to grow. To understand our journey towards AI, you need to understand where we started. We started with an investment in talent. We sent 2 classes of 6 people to Google's Advanced Solution Lab for intense training in supervised machine learning. This cohort became the foundation for our work in AI. Internally, we referred to this decision as a no-regrets decision, meaning that we were able to quickly move forward, make this investment with little or no hesitation on our part. A few keys for ROI one is don't just send IT people to this training. A lot of the value from data science in general and this program comes from the mixture of expertise and ideas that you get when you send multiple types of people to the program. The second piece of advice, and this is maybe a bit selfish on my part, is make sure you have a good commitment to work on your projects after this training. We only sent high-performing individuals to the training, and the risk with sending high-performing individuals is that they're going to get quickly pulled back into their day job, and that's definitely something we had to work through as an organization. So this investment set the groundwork to accelerate our progress that we were making as a company, and is another example of where new technologies are increasing opportunities for our employees. So from this foundation, we got to work. We went through a proof, pilot, production process, with each step being a stage gate for further investment. So starting with our proof, we built a custom TensorFlow model, leveraging the openly available Inception v3 vision model, and it worked. We were able to detect damage, but it also showed us where our shortcomings were. Our data needed work, and setting up the end-to-end platform was going to be difficult, and we were going to need some help. So in speaking with Google about our progress and our learnings, we discussed the possibility of partnering on a pilot phase. So in the pilot phase, we were using Google's data labeling service
and Google's AutoML vision tool to really accelerate our efforts and boost our efficiency. And again, it worked. False negatives were seen as a key business risk for our organization. So not detecting damage is something that we weren't willing to accept in our inspection process. So using our most restrictive precision recall metrics, during this pilot phase, we were able to show that we could eliminate 30% of the images from needing any human review. So that 4-week review process was now down to 3 weeks, really accelerating our velocity and our time to action. Time to action has really become one of those key metrics that we look at with this project. So this gave us the commitment and ability to move forward with our production environment. So our production environment is a scalable platform for us to label images, train new models, and manage those models in production. We're still iterating and refining on this model, but we're again showing some very promising results. We're now showing that we can eliminate 50% of the images from needing any human review, and the remaining 50% of the images are now categorized and classified by type of damage, further improving our time to action and focusing our engineers on the most important and most critical types of damage. So going back to data, one of the things that we had learned about early on was that our data, while we had a lot of data, it was not at the quality or level of consistency we needed for machine learning. So working with Measure, we developed a 9-category classification of damage. This includes things like cracks, gel coat damage, different types of delamination and splitting, as well as some non-damage categories like serial numbers, lightning protection points, stickers, and whatnot. So we also worked with Google's data labeling team to iterate and walk through many edge cases of different types of damage that are out there. We started with a series of batches, small in size, doing a full and complete review of all the labels that were coming back. But as the quality of labeling improved and our batch sizes improved, we've moved towards a sample basis. We also needed to develop a platform to manage the labeling effort, model training, and prediction process. Working with Google, we identified ClearObject to be our local GCP partner to help us architect and develop our platform using the latest thinking in cloud and serverless tools available from Google. ClearObject has been a great partner and worked to quickly develop this platform for us. The platform leverages AutoML for our core modeling engine, cloud storage and cloud SQL for our image repository and metadata, as well as cloud functions and app engine to manage our interactions and orchestrations. So now that we have this platform, we're continuing to improve on the model, but we're also looking to expand its use. We're looking at new business cases, solar, transmission infrastructure, and even safety, as well as looking at new inspection modalities. For example, infrared and even LiDAR. We're also looking at pushing the model to the edge, or in this case, the drone. So I'm really excited to hear about what LG is going to be sharing next. Energy is a $1 trillion business. It impacts lives in every day, in every country around the world. The challenge and the real-world impact are huge. If you're interested in working with or for a company that is improving lives by accelerating a safer, cleaner energy future, please come talk to me. Mandeep?
Thank you very much, Nick. Thank you very much, Nick, for that great presentation. So we saw how AutoML vision can be used for visual inspections to make them more easy, faster, accurate, and safer. In speaking with a lot of experts from the industry, we learned that there are some specific requirements for manufacturing use case. A lot of the time, this data sits on premise. There's latency requirements. And most of the image and data sets are in a format that requires it to be processed on the edge devices. This be a mobile phone, this be an edge TPU, a CPU, or a GPU. So with our AutoML Vision on Edge solution, you're able to take your custom-trained model and then download them in an edge device. And you can run those inferences from your edge devices. I think you'd much rather see that in action and hear directly from a manufacturing company which has deployed these models on the production line. So it's a great pleasure for me to invite Mr. Sungwook Lee from LG and share more about this initiative. Mr. Lee.
Good afternoon, everyone. I'm very thank you for your attention to our previous the presentation. My name is Sungwook Lee. I'm the Vice President of AI and Big Data Business Unit at LG CNS. It seems there are many IC specialists in our audience today. I think that if you are like me, I expect we share many great hopes to apply AI to real-world solutions. I also hope this short overview of our collaboration with Google AutoML will help you all in your AI work. Today, we'll be looking at how LG CNS and Google have successfully collaborated on AI image recognition technologies, and how we have been apply our result to vision inspection systems and several manufacturing solutions. Let's begin with a little background of LG CNS. I think you may know the name of LG Group, but you don't know about what kinds of companies in the LG Group. So I want to introduce some companies. We have LG Electronics, which produces television and refrigerator, and we have LG Display, produces world-leading OLED panel. And the LG Innotech produces a camera module. So I think half of you have already the LG Innotech's camera in your cell phone. Oh, sorry, smartphone. And LG Chemical produces electric battery. It's another world-leading company under the LG Group. So you may know almost all the LG Group companies they're working in the manufacturing industry. As LG CNS supplies the IT solutions for the LG Group affiliates and other companies working in the manufacturing industry, we are constantly working on how to best apply AI technology to improve the manufacturing processes. And we all know that it can be really challenging to use big data and AI technology to ensure product quality on a large scale production. This is where our discussion of Google AutoML comes in today. LG CNS started working with Google AutoML in the summer of last year. We started our collaboration after seeing that Google was achieving in their image recognition technology. Because we thought Google AutoML could help to improve vision inspection for LG production processes. And to our great satisfaction, our collaboration has been a success. Okay, before we work with Google AutoML, actually we had already developed our own in-house AI system. For those of you familiar with the manufacturing process, you will likely recognize the picture the left of the screen. It's the typical visual inspection system that relies on the human operators. While many production lines can have camera and IoT sensors and other detection technologies, while the many production lines can use camera, but it is still hard to find the real defect efficiently. Sometimes non-defective products are often misjudged as defective because of minor factors like small dust particles or low-resolution images, and it is still more effective rely on people to complete visual inspections. And while people get better the result, the monotony of a visual inspection made by workers also lead to many errors as well. To solve this problem, LG CNS made a transition. We moved from the traditional visual inspection, the left image you can see, to the AI inspection system shown on the right. I'm sure many of you also working on the inspection technologies, so you will be familiar the trial and error method we did to improve our system with artificial intelligence. Anyway, with our in-house system, we increased the accuracy and performance and even improved our process speed and efficiency. It means that we could reduce the operation cost also. With our in-house AI system, we were able to apply to over 30 production lines only in LG Group. Some of these include the first picture, as you can see, we could improve the defect detection in LCD and OLED panels. And on the middle of the picture, we could remove impurities from the optical film. And even improving the quality control for the production, so automotive fabrics can be made with our in-house AI system. But even with this improvement, our system wasn't working optimally because it still requires a lot of time and effort to perform well. And now, I will talk about a little about the downside of this system. As is often the case with success, we also ran into some obstacles. As we expanded the application of our AI vision inspection into other areas, we have experienced a shortage of skilled AI developers. It is very hard to hire the good AI developers for the company that are located in South Korea. So it is very hard times when the one AI developers leave our company. The bad impact is so big to our company. So and while we design the AI model, they need to spend lots of time and effort to achieve high performance. Additionally, as we develop the model using servers located at the production site, the complexity of architecture has been increased, so it is hard to be solved. So now, we require the process to centrally design and distribute the model to the edge, and to centrally control the performance of the deployed model in one integrated system. Collaboration with Google has been critical to find the solution to these problems. The performance of Google AutoML has been truly exciting, even though the AI experts doesn't like it. One of the key areas we need to improve in our AI system was our productivity in terms of the model development time. As you can see in the diagram on the left, our top arrow bar shows that it took roughly 7 days to complete our model before using AutoML. But afterwards, we brought that down to a mere 2 hours with Google AutoML. The other area we need to improve was the accuracy of our system. In addition to being faster, from the diagram on the right picture, Google AutoML's performance exceeded that of the AI experts in many times. Our test results showed the average 6% improvement in terms of performance we can expect when using Google AutoML, I think. While we have made advances using Google AutoML and integrating that with our visual inspection, we are still facing several challenges. In many cases, we could not meet our clients' requirement. And we found that many of them comes from the low image quality, not from the model that we made with Google So, to solve this problem, we recently launched an image pre-processing research team. The members of this team spend more time on exploratory data analysis and pre-processing data, and try hard to augment data for getting better machine learning models. So they became to spend a lot of time on thinking how to change the inspection process itself. I estimate now our members could use their time and effort for more strategic work. Now, we are planning to expand our business into consulting services. So, we will provide expertise to enhance overall inspection processes as one-stop solution. We are hopeful that we will see the first manufacturing visual inspection area where humans and AI share areas, the responsibility very optimally. Do you agree? Okay. I would like to announce that we have built integrated AI vision inspection architecture. So our system and Google AutoML is connected seamlessly. With this architecture, we will be able to maximize humans' capability and utilization of Google AutoML. This architecture starts from the data scientist part, the bottom. They will ensure image quality. So they will produce a clear image and will send to the Google AutoML. And Google AutoML takes the clear image and produce AI model with efficiency and with effectiveness also. The models will be completely managed with all the history data and performance status and automated relearning processes. With this architecture, the LG group is now can develop and manage thousands of AI models simultaneously. In addition to vision inspection, our goal is to expand the architecture to the other manufacturing use cases to manage the whole factory equipment, facilities, and safe things, and so on. I think you may think of many use cases we can expand this integrated architecture in the manufacturing industry. To this point, we have gone over how collaboration with Google AutoML has improved our visual inspection systems. Now, let's look at to the future. Based on our AI integration success within the LG Group, we will keep going to be positioned as a leading AI visual inspection total service provider. So we will cover from the pre-processing area, and we will cover learning the model, and then we will manage all the models made with Google AutoML. Whether the cause of poor inspection quality is machine learning equipment, or the image quality, or data labeling, or the operators themselves, working with Google AutoML, we will strive to achieve our goal of 19.9% accuracy and the leak rate of 0.001% under all conditions. If you are experiencing the similar issues in your industry, I hope that this session could be helpful. I really appreciate your attention, and thank you for listening. Thank you.
Thank you, Mr. Lee. Thank you, Mr. Lee. So the goal that Mr. Lee shared about LG is very much what we share for our product and for our roadmap as well, which is to make our inferences faster, our interfaces more intuitive and easier, and our results more accurate. Within manufacturing, we're seeing many more use cases beyond automotive, beyond electronics, into the food, into retail, and many more categories. And we are very excited to work on these new use cases with you. We saw how AI and visual inspection can be applied to the manufacturing use cases, and we looked at how this can be applied for the aerial inspection use cases. Beyond the 3 use cases that we talked about on the aerial inspection side, we're also exploring more work on the agriculture monitoring and construction site monitoring. As of today, this technology is available to use in beta. Please visit cloud.google.com/vision to register your interest. You can use the technology right away, but by registering at this site, we are able to partner with you and work with you on our upcoming releases and our early access program. So we look forward to hearing from you. Thank you so much for joining us in this shared vision. And we really look forward to working with you in creating a more brighter, more greener, and more positive future. Thank you very much all.